galaxy, beyond the galaxy. Now, there's no way the Russians could shoot explosions in outer space beyond the galaxy. And then people began to realize that we were staring something new in the face.
They were super powerful explosions of high energy radiation called gamma ray bursts. And they were coming from exploding hypernovas. During a normal supernova explosion, gravity crushes a star's core into a neutron star. But during a hypernova explosion, the giant star is so much bigger that gravity crushes the core into something much stranger. A black hole. And the black hole immediately begins to devour the dying star around it.
The rest of the star can't all go in that little bitty hole in the middle. It starts to swirl around and it forms an accretion disk, which is feeding the black hole at about 1 million Earth masses a second. And so, as you might imagine, something dramatic is going to happen here.
1 million Earth masses a second is too much for the black hole to consume all at once. So it discharges a lot of it back out at nearly the speed of light. This creates two beams of pure energy, blasting their way out of the black hole.
It takes it about 8 seconds to bore through the star, keeping a very tight focus, and erupt from the surface. Now, if we're standing in the opening of this jet, we'll see a gamma ray burst.
The gamma rays produced from the black hole tear through the outer layers of the star and into space.
Gamma ray bursts are the most violent event that we know of in the universe. A giant star blows itself to pieces and forms a black hole. It's incredibly spectacular.
These gamma ray bursts are so energetic, they light up the entire universe. Any point in the universe will eventually pick up this astounding radiation coming from a gamma ray burst. That's how energetic they are.
They are the brightest things in the known universe.
To put things in perspective, a typical supernova explosion is about what the sun will put out in its entire 10 billion year lifetime. A gamma ray burst viewed jet on is 100 million times more luminous than a supernova. They're the champions for brightness, for sure.
Not only are they bright, they're also lethal. If a gamma ray burst were to hit the Earth, it would destroy most of the atmosphere in seconds.
A gamma ray burster is like a rifle shot. And if you're in the line of sight, watch out. Once the radiation hits you, it'll bathe the entire surface of the Earth with nitric oxides, which will wipe out the ozone layer. Blistering radiation would hit plant life, hit algae. The whole food chain would collapse.
If the burst was close enough, it would cause mass extinctions.
Gamma ray bursts turn out to be a lot more common than we thought they would be. So it's possible that some of these have even hit the Earth in the past. That's a pretty scary scenario. It may already have happened.
In fact, there is evidence to support the theory of a gamma ray burst causing mass extinction here on Earth. Millions of years ago, creatures called trilobites lived in the oceans.
Long ago, the trilobites were masters of the universe. They ruled the ocean. They were the dominant life form. And then one day, 250 million years ago, they all died. In fact, 90% of life forms on the Earth suddenly vanish without a trace.
Scientists now think the extinction was caused by a gamma-ray burst. But if it's happened before, could Earth be in danger from another gamma-ray burst?
A gamma-ray burster is basically a supernova on steroids. You need a giant star to die violently. Now, the nearest star to us that might do that is Eta Carina, and it's a spectacular nebula. There's all kinds of material flying off this star. It's very unstable. It may already have exploded in a gamma-ray burst.
But Eta Carinae may not be the only threat. There are other dying stars in the universe.
Believe it or not, one of them is pointed in our direction. We are staring down the gun barrel of WR-104, two dying stars that will one day undergo a gamma-ray burst. Not a question of if, a question of when. That WR-104 may have our name on it.
But the good news is we probably wouldn't know about it in advance. The shock would hit us before we had a chance to do anything. So there's no sense worrying about it anyway.
And we'll never know if a star is about to go hypernova and explode. Even if we did, by the time we see it, it'll already be too late. In fact, we're already exposed to rays from dying stars every second of every day.
Journeys, Monday to Friday at 5:40. All new on Discovery HD Showcase.
When giant stars explode, they make the biggest bangs in the universe. But until recently, no one knew what gave them so much power.
Scientists, when they tried to simulate a supernova explosion in a computer, had a problem. They simply could not get enough energy out of the dying star to create a supernova. This was a calamity in astronomy.
Computer models couldn't make the simulated stars explode. To blow up a star, you need a lot of energy. The problem for astronomers was they just couldn't find it.
The visible radiation that you see is a tiny fraction of the total energy emitted. Even the energy of motion of the expanding gases is only 1% of the total energy.
Where was the missing 99% of the energy from the explosion? The only way scientists could get their simulations to match a real explosion was to add in a mysterious particle called the neutrino. Without it, their calculations didn't work. The hard part was the next step, to prove that supernovas actually do produce neutrinos. Then, in 1987, fortune shone on the scientific world. 168,000 years ago, a supernova exploded in a nearby galaxy called the Large Magellanic Cloud. When scientists saw the light from the blast, they called it Supernova 1987A.
Supernova 1987A is really important in the study of supernovae because it's the first one since the invention of the telescope. It's the one that we've been able to study right from the time of explosion through now using all the instruments that we've developed.
One of those instruments was a giant neutrino detector, buried deep underground.
And bingo! We saw a burst of radiation go through our neutrino detectors, and we said, aha! That's the proof.
The discovery of neutrinos from supernova 1987A was a tremendous thing because for many years people had been saying that's where 99% of the energy goes, but no one had ever seen it.
This is now the smoking gun that we can now prove that neutrinos carry the energy of a supernova, and we detected it right on the Earth as we saw a supernova in outer space.
Neutrinos are trillions of times smaller than atoms. They're created by all sorts of nuclear reactions. From nuclear power plants and bombs to exploding stars. If you were able to, you would see neutrinos everywhere.
Neutrinos are ghost-like particles. Literally trillions of them are going through my body even as we speak. In fact, neutrinos come from the bottom of the floor right through the Earth and even hit me right through my legs.
Imagine so many tiny particles zooming through our bodies. But from where does all their energy come? When a core collapses just before a supernova explosion, the atoms inside it are broken.